Welcome to Analyzer Shorts, the series where we show you bits and pieces of AnalyzerPro in order to inspire and help you in your daily work as an expert. Today we're going to talk about the tracking analysis module in combination with momentum backward collision analysis. So nowadays most people are used to do a forward simulation when doing a collision analysis, and that's also possible in Analyzer. But the more classical approach, I would even say, is the tracking analysis and momentum backward. So what's the main difference? With this method, we are trying to elaborate the behavior of the cars post-collision and working our way back from the end to the collision point, and from that we get the vectors of momentum post-collision, and out of them we can calculate the vectors of momentum pre-collision. And this method works great if you have traces, if you have a good idea about how the run out of the cars was after the collision. Then it's way more efficient to do a forward simulation. And let's dive into it. So I'm opening the module, and what I'm going to do now is I have now several silhouettes of cars here marked with 0, then marked with 1, and what I have to do now is I have to mark positions where the car has been at a certain point, and the final position is the position 0. So I'm putting that here. I'm putting, and now probably I switch off the DXF shapes because then I can see where the wheels are. So now I can, for example, see, okay, this trace belongs to the top, to the front left wheel. So I might place it here, change my rotation point to this point, and then rotate it in a way that the traces match. So I can see, okay, this is the right front wheel, so the right front wheel must also be on that trace. This is the right rear wheel, must be here. And then I can add a new position and work my way back all these in-between positions. Furthermore, we have two ways of letting a vehicle decelerate in that setup. One is through braking, and the other one is through sidewise gliding. So if the wheel just slides sidewise and not in rolling direction, of course it will decelerate the vehicle. For the friction of the vehicle between vehicle and ground, or wheels and ground, we have a friction value here. Please note that this is an average friction value for all four wheels. So if one wheel is, let's say, covered in oil, the whole friction value will go proportionally down. Same goes for partial braking force. So this is a value between 0 and 1. 0 means all wheels can rotate freely, and 1 means that all four wheels are completely blocked. I will now make a fast forward and place all the vehicle positions. Now you can see all the in-between positions I have done for the blue car and the red car. I've put in friction and I have put in partial braking, and I ended up in their point of collision, so the point with the deepest intrusion that you might already know from the collision analysis in the momentum forward method. We also get the speed post-collision for both cars. And now what we have to do is we need to do a collision analysis. Clicking on collision analysis, we can have the detailed or the less detailed view. And now the runout values are automatically put in, and our K value and our friction value between the two cars are a result. So this is a good way of double checking if your result is valid and correct. Out of that, we automatically get then our collision velocity for both cars. We could change slip angle or rotation velocity if there was any before the impact. And that's it. As usual, the module will fill up faces in the main data window, and we can continue with our pre-collision calculation. I hope you enjoyed today's video. I wish you a great day, and goodbye.